We have arrived at our final topic. No tears, please. Here's where we left off with a nice little cliffhanger to be continued. The limit of the function as x approaches 3. We got two different answers depending on where we were coming from. Coming from this side, as x gets closer and closer to 3, y was getting closer and closer to -2. As we approach 3 from here, x is getting closer to 3, y is getting closer to 2. And we had a conflict. This is where we resolve the conflict, but not right this second. First, we need to review a little notation. We know that this notation means the limit of the function as x approaches some number c. We have to assume, in fact, this notation means we are approaching from both sides simultaneously. Like in this example, we approached -2. We had to approach from both directions. Approach -2 from this side, approach -2 from this side. What is happening to y? And we found that in this example it was -1. Both sides. In these examples, we had to approach from both sides simultaneously. Well, let's say we don't want to do that every single time. Let's say sometimes we might want to approach just from one side or just another side. Here's how we do that. We have the limit of the function as x approaches c with this little plus. This is not an exponent. It is not something that says this is a positive or a negative number. Over here, we have the same thing, only it's negative. Positive, negative, no. They do not mean positive, negative. They do not mean exponents. What they mean is right and left hand limits. This is a right hand limit. We are approaching c from the positive side. In other words, we are starting to the right of c, and we are approaching it from the right, from the positive side. We are approaching c, in this case, from the negative or from the left-hand side. That is what those notations refer to. So think of this. Think of this as a right-hand limit. Sometimes it's abbreviated RHL. Left-hand limit. Approach from the left. Approach from the right. If the right-hand limit is not equal to the left-hand limit, then we say that the limit does not exist. When the two sides agree, then we have a limit of the function at that value. When they don't agree, we say nobody wins and there is no limit. Now, let's not confuse this too much. Let's not say that, well, if these aren't equal, then there's no limit, period. There's still a right-hand limit. there is still a left-hand limit, but there is no function limit. These three are their own separate limits. This is the limit of the function from both sides simultaneously. Sometimes we can't do that. Sometimes we can only approach from one side or another. Sometimes there is only one side we can approach from, based on how the function's defined. Sometimes we cannot approach from the left. A simple function that we cannot approach from the left would be the square root function. How do you approach from the left to 0? There's nothing to approach. There's no part of the function that's over here. So if I were to ask you what's the limit of the square root of x as x approaches 0 from the left, we would say it does not exist. We cannot approach from the left. We can approach from the right. As we approach 0 from the right, what's happening to y? It's getting closer and closer and closer to 0. It has a right-hand limit. It has no left-hand limit. So, in general, limit square root of x, x approaches 0. There is none, because I cannot approach from both sides. There's no part of the graph over here. It has a right-hand limit only. And I could reverse that. I could create a function that only goes to the left and has no right-hand limit, but it has a left-hand limit. So some functions are like that. Some functions only have one hand or the other. Some functions have both hands that go to different places. Some functions behave and have their right and left hands go to the same place. Therefore, the function itself has a limit. And we saw some of those earlier. Whoops, too far. These are all functions, or these were all limits that exist. Approach 1. From the right and from the left, it was the same thing. So the limit existed. Approach 4. From both sides, same thing. Approach -1. Both sides, same thing. Approach -2. Both sides, same thing. Here we had conflict. We had two different results. We are now ready to answer that question. The limit of f of x as x approaches 3 from the right. Approach it from the right. X gets closer and closer and closer to 3. What's happening to y? We said it was going to -2. The limit of f of x as x approaches as x approaches 3 from the left. Approach 3 from the left. We get closer and closer and closer to 2. The limit as we approach 3 from both sides at the same time does not exist. Does not exist. Sometimes we simply say there is no limit. That's what does not exist mean. There is no limit because the two separate limits do not agree. So therefore, the function has none as it approaches that point. It has a right-hand limit, it has a left-hand limit, but because they don't agree, the function in general at that value has no limit. Here's another function. Not shown. I will draw it in here. There's a vertical asymptote. What is the limit of the function as x approaches 2 from the right? What's happening to y? It's getting bigger, getting bigger, getting bigger. That will actually keep continuing on forever. Added arrows on these. There we go. As x gets closer and closer and closer to 2, y is growing, 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 growing. It is growing without bound. It's growing forever. There is no number it's getting close to. It is just growing forever. There is no limit there. Does not exist. Now, those of you that take calculus, some calculus books will say the limit is infinity because it is growing forever. It is continuously rising. To avoid some confusion in the short term, let's stick with does not exist. Let's leave infinity till the fall, because it's not always going to be infinity. Let's leave infinity alone for the moment. If there is no limit, let's stick with does not exist. Let's approach 2 from the left. We're approaching 2. What's happening to y? It's getting bigger, but in the negative direction. It's not approaching anything. It's continuously falling. As we get closer and closer and closer to 2, this is falling faster and faster and faster. Again, there is no limit. Does not exist. So the limit of the function as we approach 2, there is none. I'm going to get rid of this. There we go. Don't want to stoke any confusion. We'll save the infinities for the fall with limits. So here it's possible where we have does not exist everywhere. For a function to have a limit, or a right-hand or a left-hand limit, it has to be going, it has to be approaching a value. This is rising, this is falling forever. It's not approaching any value. It's just continuously growing, faster and faster and faster, continuously falling faster and faster and faster. It's not going anywhere. Not approaching a value. Also notice that this was rising, this was falling. They were going in opposite directions. These are going in the same direction. The limit as we approach 3 from the right. Nope. We're not going to a number. Let's approach 3 from the left. We're still rising forever. Now, even though they're going the same direction, they're not going to a particular number. Still no limit. Here's a limit. Limit of f of x as x approaches 1. There's a limit. As x approaches 1 from the left, as x approaches 1 from the right, we see the number 2. That will conclude our work with limits. And that concludes all our new material for pre-calculus.